Hi everybody. So before we start our session today, please confirm if you are able to see my screen and able to hear me. Okay. Thanks for that confirmation. Let's get to the topic what we plan to cover today. It is about how to build the neural network in Python. So this is one of the interesting topics which will give us good insight in terms of what exactly is neural network, how exactly we train the neural network, and how exactly we build it. So let me go ahead and see what is our planned agenda for today. This way we can know how exactly the overall structure unfolds. So we will get with a brief introduction to Python. Then we will get into the section where we will try to talk about neural networks. So what is neural networks, why neural networks is the place what we try to cover in this section. Then we will get into the motivation, what drives the neural networks. Once we understand the motivation, we understand the W of it, which is the what is neural network or what are neural networks. Then we understand some technical nitty-gritties within neural network, which is a single layer perceptron, multi-layer perceptron, and then finally we will get into the applications of neural network. So this way we get an insight in terms of how, where, what is neural network. Let's get into the section now. So to start with, what is Python? Right, so most of us understand there are various programming languages, right? And when we have so many programming languages, why exactly we need one other programming language, which is Python? So Python is a programming language which was created to help statisticians. So what does that mean? When there were so many other programming languages already available, what was the need to create one other programming language to help statisticians? The whole question here is the programming languages which were created, all of them had a reason and an intent. For example, if you happen to look at the Java programming language, Java was created more for an application programming front, which means with Java, creation of applications is very simple and easy, which means the intent is achieved for application creation. While the statisticians are the people who work with lot of data, and when you say work with lot of data, there are various activities which are involved when you have to deal with data. It could be collecting data, transforming data, visualizing data, or analyzing data. To do all of this, there was no specific programming language, and hence the Dutch programmer by name Rossum introduced or created a programming language called as Python. So he named this programming language as Python because of he was inspired by his favorite show called Flying Circus, and that's the creator of that Flying Circle was Monty Python. So from his name, he gave this programming language name as Python. So that's a brief history in terms of what gave or what is the reason for the birth of this programming language Python. But coming to what is Python, Python is a programming language which supports both conventional programming approach and object oriented programming. So when I say conventional programming, we always call it as procedural programming, like C, Pascal, they were all procedural programming. And Java, C++, .NET are having the capabilities of both procedural programming plus your object oriented programming. So Python supports both of them. So just to understand what is procedural programming, it is an approach where you have a predefined procedure and you have to follow that procedure to get an execution. So for example, if you have to sum 2 plus 2 is equal to 4, the way we write the code in a procedural programming is we define the variables, which is the first block. definition block, what we call. We do the computation where we do 2 plus 2 is equal to 4. That is your computation block. And then the final block, which is the print block, where we define or where we get the output. So you just cannot interchange any blocks, and they have to follow this procedure before the execution happens. While an object oriented approach is an approach of dividing the whole problem into smaller problems and building the solutions to the smaller problems so that those solutions can be reused, and when we combine those smaller solutions, we get the solutions for our bigger problem. So that approach of programming is object oriented programming. Python supports both of them, and Python is an open source programming language. What is open source? Which means there is no license fee which is required, and it is maintained and managed by the community. So for that reason, you have to call them as open source programming. So it is free for commercial or learning, whatever the purpose might be, it is free to use and easy to learn. So easy to learn is a very subjective thing, but still the reason is, being a programming language derived out of C programming, the syntax tallies more or less with Java and other scripting languages like Perl. So people who already know these programming languages, it becomes immensely easy for them to learn this programming language which is Python. The last but not the least, it has a large inventory of functions which are grouped as libraries. So what is a function? A function is a small piece of code which can address a small issue. So there are more than 15,000 plus functions which are available in Python, making one of the programming language with the highest inventory of libraries. So what's happening is the requirement to write code is reducing, and the necessity to use or leverage the already available libraries is increasing. That way it helps you to do the things very easily. So these all aspects make Python one of the highest adapted programming language. With this, let's see what are some of the features of Python. So having a vast variety of actions, Python is simple to write. In sense, the simplicity makes the limited or minimal complexity with regard to coding. So the syntax is straightforward, straight across. Therefore, it is one of the easy on developers. The second one is on the open source, which we already spoke. So, which is free for everyone to use. There is no licensing, there is no costing which is to be factored in when you are developing anything with Python. The third one is the portability. So what is portability? In sense, the code which is written in one operating system can easily work in the other operating system. So you write a code on a Windows and you can use the same thing on a Mac, or you can use the same thing on a Linux. So the portability makes code sharing much easier. Then it also has a good compatibility with other programming languages like C, C++, Java, making things even more merrier. So you write a code in Python, you can integrate easily. So that way, if you have applications which are running on other software programming languages, you don't have to really worry too much about the integration quotient, making the things even more powerful. Then it is interpreted. What is interpreted? It is the CPU which manages the memory. Therefore, Python becomes very resource managing software. So you don't have to really worry about the CPU managing the resources. The interpreter within Python manages the memory, and that way it knows when to release, when to hold, what to release. All of this is maintained by the Python interpreter. Then comes the huge libraries which we were talking. Some of the eminent libraries like NumPy, Matplotlib, scikit-learn are Seaborn, they all have a huge inventory of library functions, making the things to reduce the complexity. And like we say, object oriented program, it breaks the complex problems into simple things so that you can get solutions in a better approachable manner. That all of things makes Python one of the most adapted programming language. And as per the recent survey, Python is the second highest adapted programming language in the world, and 5 to 7 years back, it was not even in top 15. Today, it is the second highest adapted programming language. So, with all these features, Python is gaining its importance and relevance. With this, let's come to our topic of the day, which is neural network. So, basically, if you happen to see, a computer by itself is a step-by-step execution system, which means whatever we write the code, right? The code is conditional by nature, and whenever the conditions don't match, we just write one or two exceptions or scenarios for exception and then close the activity. But for any change in instances which are totally unpredictable, we need to bring a quotient of learning, which means the programming by itself cannot do a learning based on number of times it executes. Right? So, from that particular thing, the computer will not be able to solve the problems where there is no code available, which means the problem solving capabilities of a computer becomes very restrictive in nature. To address this issue of restrictiveness, to understand this or to address this restrictiveness, we have to use some other means, and that is where the neural networks comes into our rescue. So, to solve the restrictiveness from the problem solving capabilities, the neural network helps us, right? So, neural network basically, if you happen to see the way the neural network works, is you have an input layer, then you have a one to many connections, and this one to many connections become more and more with multiple layers in between, which are called as the hidden layers. Then you have a final layer, which is an output layer. So basically you are creating a matrix with one to many relations, and thereby you are saying for the changing inputs you can get the changing outputs. So that's where we try to coin the word a neural network learns by example. So if you see today a human baby or a animal, they try to do things by learning. So seeding this quotient of learning into an application is by means of one of the approaches, which is neural network. So neural network by image or by the framework, this is a simple neural network. This part is our input layer, this is our hidden layer, this is our output layer. So with this, let's see what exactly motivated humankind to call this as neural network. So the human brain consists of a cell called as neuron, and there are billions or rather at least millions of neurons in every human being. This was the motivation to create an artificial neural network, and the biological diagram of a neuron is something like this. It has a dendrite, which is a area which receives the signal from other neurons. Then you have the cell body. It is the area which sums up all the inputs. Then you have the axon used to transmit signals into other cells. So this neuron became a motivational factor to create an artificially enabled neurons. If you happen to see, a combination of such neurons becomes a neural network. So, what is a neural network or artificial neural networks? It is predominantly called as ANN. What you see here is a very, very interesting image. You are seeing some kinds of dogs, and you are showing an application which has a photo of a family with a dog. But if you see the dog which is there in this photo versus the dogs which we train the application is very different, which means in spite of training an application based on the various images of dogs, a regular machine learning algorithm which can handle structured data fails, which means it will not be able to identify there is a dog in this picture. Unlike a human being, today most of you are seeing this slide for the first time and you are able to recognize there are four human beings, one dog in this photo, and you say there is a father, there is a mother, there is a boy child and a girl child with a dog. How did you do that? Which means for a minute, if you stick back, you have never seen these cartoon images. Or rather, this is the first time you are seeing the photo of these people, and still you are able to identify there is an adult man, adult woman, baby boy, and a baby girl with a puppy. To make a machine get the same level of understanding, neural network becomes handy, which means with neural network, you will be able to make the application understand what it is. So if you see this, this is an artificial neural network, how it looks by image. So here we have a biological neuron and we have an artificial neuron. So, how a dendrite axon receives the data. So, this is the dendrite, right? Which receives the data. We have our input layer x1, x2, x3, xn are all our input layers. Then we have a processing element where all the inputs we get based on the weight. So, what is the weight? We will talk about it. The factor of importance what we give is a weight. Basically the input with weight becomes your processing. Then we have a transfer function, which means whatever is the data which is processed based on a trigger, the output is fired. That's where we call a neuron fire or fire the output. So that is where you have the f of s or function transfer function which results in your output. In this case, here is your outputs which become the input for your next neuron. So you try to build multiple artificial neurons and make a network which eventually gets called as neural network. So every new artificial neuron has an input, has an output. So what we do here is there are various modes in perceptron. So here this particular thing, whatever we call the artificial neuron is called as perceptron. So there are various modes in perceptron. One is the training mode and using mode. So it is like this, right? When we are kids, we go to the school, we learn something, and when we are adults, we go ahead and leverage what we have learned. So here also we have a training mode and an using mode. So the same thing what we have as a human being, we try to take this. So that way you get to see. So with this, let's see how exactly we get into our activation. So if you remember, I said there is a transfer function wherein we have an input, we have a wait, there is a processing, and then you have a transfer function. The transfer function predominantly works on your activation. There are various kinds of activation functions: step up function, sigmoid function, sine function. So basically, if the value is between a -1 to +1, you use the sine function. If it is between 0 to 1, you use a step function. If it is an S or yes mode, we use a sigmoid function. So activation is the various functions which we use. Let's understand the whole analogy whatever we spoke with a simple analogy. Thereby we will be able to get the most of it. There is a beer festival near your house. Okay, it's a weekend, you have a beer festival near your house, and you are thinking whether to go to the beer festival or not go to the beer festival. The factors which help you to decide whether to go or not to go are three facts. How is the weather? Is your spouse accompanying you? And is any public transport available? So these three factors are the ones which helps you to decide whether to do or not to do. Now what you do is, basically for every question you had two outputs. One, basically if the weather is good, you say the output of this question will be 1. If the weather is bad, the output is 0. If your spouse is accompanying you for a beer festival, it is 1. If not accompanying, it's 0. If there is a public transport which is available, it is 1. If the public transport is not available, it is 0, which means you had 3 inputs. For every input, you have 2 options. For all the options, you have a value assigned to it. Now, based on this, if the value adds up to 1, you are going to the beer festival. If the value adds up to 0, you sit back home, enjoy Netflix. Right? So, this is your output. But how does that output get created? Let's get to see. So, basically, suppose for you the most important factor is the weather. While you are okay with spouse accompanying or not accompanying, and public transport availability or not available, you are okay, which means the weight what you give for weather is higher in comparison to the other two inputs. This is how it works. Let's get to see how exactly this happens. Now if you see this, we have to assign the weights. What happens here? We have 3 questions, right? The inputs are 3. Therefore, the weight for the first input will become W1, the weight for the second input will become W2, the weight for the third input becomes your W3. Then we have W1 is equal, let's assume we assign a weight for our first input, which is the weather, which is 6. Weight for our second input is equal to 2. Weight for our third input, which is the public transport. The 2 is the spouse accompanying, 3 W3 is the public transport available. Now, if you happen to see this, we have a weight W1 is equal to 6, W2 is equal to 2, W3 is equal to 2. Now, the threshold value is 5. Now, we have our x1. Assume the weather is good. 1 into 6, because our weight for this input is 6. Weather is good, therefore 1. Then assume spouse is not accompanying you, which means 0 into 2. And we will also assume there is no public transport, which is 0 into 2. Therefore, if you add this up, 6 plus 0, we get the first input as 6, while the threshold value is 5. 6 is greater than 5, which means we will go to the beer party. Assume we change the weights, where I say the weight is 6, 2 and 2, or rather we are not changing the weights, we are changing the threshold. Now we say in this case the weather is bad, which means 0 into 6. Assume the spouse is accompanying you for the beer party, which is 1 into 2, and we also have public transport available into 2, 1 into 2, which means 0 into 6 is 0, 1 into 2 is 2, plus 1 into 2 is 2, which is 4, while our threshold value was 3. So 4 is greater than 3, therefore you will go to the beer party. If this was the scenario and your threshold was 5, 4 is less than 5, which means you are not going to the beer party. So the transfer function gets fired based on this condition. This way, the weight assigned for every input, when we keep changing, we keep seeing how exactly they behave and then get to our output. So with this, let's go ahead and see what is the multi-layer perceptron. So we saw a single layer, right, where we have a single input process and coming. When we combine multiple single neurons, it becomes a neural network or multi-layer perceptron. So what happens here in multi-layer perceptron? As we saw, this is our input layer, this is our hidden layer, and this is our output layer. So the brain, which is made up of multiple millions of neurons, a neural network is really just a composition of multiple neurons, artificial neurons or perceptrons, connected in different ways and operating on different activation functions. So if you happen to see this, this is an example of artificial neural network, which is a multi-layer perceptron. So if you happen to see a group photo, for example, your childhood school group photo or college group photo, and you are trying to identify one of your close friend, and it has been like 5-10 years, you have completed your schooling and now you are trying to find somebody, how do you do that? You first try to identify the various faces, which is the patterns of local contrast, because in a group photo there can be multiple other objects, there can be people, there can be benches, there can be sky, it could be outdoor, it could be indoor. So basically you first try to look at one of the things where you are trying to concentrate is the faces, which is patterns of local contrast. From this you go and identify the face features, where you say I want, based on whom you are trying to search, whether it is a male or a female, you try to identify some of the features of the face, like woman having a long hair, men having a short hair, all those features. Then you identify the face, and finally you recognize this is the person whom you are looking for, which means there was a multiple layer of activities which you did in sequence, and that is what we are trying to do it here. All right. So that is the place where we give this. So with this being the thing, let's get to see how exactly we have to train a neural network. This is something which will help you to understand whatever we spoke, what exactly works here. Now if you see, we have two columns here where we have an input column and a desired output column. So what happens, I have an input as 0, 1 and 2. I have my desired output as 0, 1 and 4. So by seeing the input and output, we know it is the square of this. 0 square is 0, 1 square is 1, 2 square is 4. That is how our desired output or the expected output. Now what we go ahead and do to train a neural network, first we go ahead, give a weight with a starting weight. Okay, now I give a weight as 3, w is equal to 3. Now what I have to do is, with this weight I will go ahead and multiply my input. 3 into 0 is 0, 3 into 1 is 3, 3 into 2 is 6. Therefore my first model output with the weight 3, I get 0, 3 and 6. For this I go ahead and calculate my absolute error and square error. So my absolute error is 0 minus my desired output, which is 0. 3 minus 2 is 1. 6 minus 4, which is my 4 is my desired output, 6 is the model output. Therefore I get 6 minus 4 is 2. The square error of my absolute error is 0. 1 square is 1, 2 square is 4. Now I got, for this model output where w is equal to 3, I got my squared error as 0, 1 and 4. Now I will go ahead and change my weight from 3 to 4. So I get the values 0, 4 and 8, which is 4 into 0 is 0, 4 into 1 is 4, 4 into 2 is 8. Now I go here, I see I get my absolute and squared error directly. Square of 0, 4 and 16. 0, 4, 16, I get the error. So I keep changing the weights continuously, like what I did with 3, 4, 5, 6, and then I derive to see, with the increase in the weight, is my error increasing or decreasing? By this, I identify a threshold point when I should stop increasing or decreasing. In this case, this is that point, and that is how I go ahead and train my neural network. This way, you go ahead, do the various things and get your aspects in terms of what is available, what is not available, and get to see your things as of your training nature. So with the increase in the weight or with the decrease in the weight, if the error is increasing or decreasing, that will determine your threshold. That's why neural networks are resource intensive, which means it will have to, if you have, imagine we have 3 inputs here, and if you say you have to change the weights, we have a weight changing, incrementing it. If you do the increment very small, for example, in our example we were incrementing it by 1, you can increment by 0.1, 3.1, 3.2, 3.3. For everything it has to do the calculation. So doing so many calculations, tabulating them to see what is the means of increasing or decreasing the error, therefore your neural network becomes really computational intensive. That is why whenever you happen to run your neural networks or any deep learning algorithms, you need to have higher RAM, higher processing units to enable such calculations. So all these particular things gave us an insight saying how exactly we leverage the neural networks. So where are these neural networks used? various placeholders, right? So I just used an example to start with 3. You can always you start with 1, 2, go all the way, or come down. That way, by increase or decrease how exactly this can be used. The activation function is used whenever you have to get the output. So basically, if you see in our thing, we use an activation function to compare the desired output with our threshold, and whenever the result matched, it is greater than or less than, we used a transfer function which is called as the activation function. Okay, so definitely we can use the equations for decreasing the error. The example what I showed you to is to tell you how exactly the neural network training happens. So you have three variables, right? Here you have the input variable, desired output variable, the weight variable, and you are trying to do a calculation against all these three and reading the pattern, and then making a system accommodate based on the results. That accommodation based on the result is the learning quotient what you give. So if you look back, if you today go to a buffet which is of a cuisine which you usually know, you can easily identify what each and every item is. How do you identify that? Based on your previous experiences and based on the new inputs what you are getting. For example, you have a dish which is an South Indian breakfast item. Since if you are having that food always, you know what each of this item is and you are able to relate it. But imagine there is a new item which is a pancake. Probably most of us might not have heard about pancake. You might misinterpret that for an Indian dish, which means the error is higher. At the same time, imagine a dish which you have not even seen, some Mongolian dish or some Spanish dish. Probably you are having a wide range of error, which means in that split second your brain is trying to do this permutation combination to relate with whatever the information you previously had, which means you have a new input which is your input layer, you have your desired layer which is the inputs already with you or the information already with you, and your brain is trying to compare both of them, do this complete calculation. Wherever it matches, then it tries to give. For example, will you name a dosa as an idli? Probably not, which means you just cannot take a desired input versus an output. At that cases, it is immensely higher quotient of error. So the same phenomenon we are trying to use in a neural network. What I will do is, let me take you to a simple code where we see how exactly the neural network is functioning. We have a simple code here, and I have a data where, let me open this Excel. All that we have is basically I have a data where we have certain features of a currency note. So what has been done is, based on the various currency notes, we have captured the various data instances like variance, skewness, kurtosis, entropy, and then we classify whether a given currency note is a valid one or a fake one. So if you see the classification which is column E is either 0 or 1, right? So let me go ahead, put a filter so that I can show you. There are two outputs. So which is our 0 and 1. So 1 is all our valid nodes, 0 is all the ones which are the fake nodes. Based on the various inputs, so the variance, skewness, kurtosis, and entropy are the ones which help you to classify whether it is a valid one or a fake one. What we are doing is, we are writing a simple neural network here. So now if you see this particular thing, this is a code which has a combination of Python and TensorFlow. Basically, TensorFlow is a library in Python. We are using both of this and Matplotlib library to get our visualization. So I am importing my library, then I'm importing my TensorFlow, then I am importing my data set, which is the banknote authentication data set, which we just saw. Once we do that, we'll have to define an encoder function. Then we read the data set, the x and y, and we try to convert the data set into the division by testing and training. We are splitting this into 80-20. So test for testing we do 20%, for training we use 80% of the data. Then what I am doing is I'm defining the important parameters, and I try to build a model which can be used to identify when a new input is given, whether it is a valid node or a fake node. Now I also, since I have all this data, I go ahead and try defining my hidden layers. This program what I've created is a 4-layer neural network. Therefore hidden layer 1, 2, 3, 4 is created. Then we go ahead and create this model, which is our multi-layer perceptron. If you see here, before I create the hidden layer, I start with a learning rate, which is the weight. Here I start with 0.3, which means I increment with 0.3, and I am saying I will train this model 100 times, which is my epoch. Epoch is the number of iterations. Now I have trained my model 100 times. The more I train, the better becomes your model. Now once I define all my layers, each and every layer I have a different activation functions. For the first layer I use a ReLU activation, second layer I use sigmoid, third layer I use sigmoid, the fourth one is again a ReLU, the output layer is on a linear activation. Then I go ahead and define my weights and bias for each and every layer. And once I get all of this particular thing, I am using the various functions of my TensorFlow, and I calculate the cost and accuracy for each and every epoch or iteration. Once I calculate that particular thing, I am saving my model in a specified path, and then I go ahead and plot my accuracy. If you see, usually this takes little bit of time, around 5-10 minutes for you to run. So I have just run this code few minutes back. Now if you see this particular thing, the first iteration epoch 0, if you see, the training accuracy was 68%. The mean squared error was 0.72, and it started with an accuracy of 68%. With every epoch, the change in the accuracy started increasing. So it is increasing, and there will be some fluctuations also. And if you come back, this is the iteration number 47, 48, 49, all this particular thing. So if you come down, this is how my model got trained. Now if you see this, it started around 68%. Here it started going up, going down, going up, going down. Around 45th or 47th iteration, it is around 96%. So you see here, let me bring this up. Around 49th iteration, it is around 99%, and eventually it increased to almost 100%. Therefore it sees there is a good accuracy, there is very limited mean squared error. Now this is the model. So if you see, if I run this, let me see, usually it should take some time. I can show you the epochs. Okay, you see this, the epoch started 0th epoch, which started this time with 61%. It is increasing with each and every epoch. We had 4 input layers, which is going across the 4 hidden layers. And if you see, around 35th, 80% accuracy is it is going now, 81%, 82%. With every epoch it keeps increasing. So this way I can increase the epochs, the change my variables, inputs, all of this particular thing, and then I get to my final epoch, which is the 100th epoch, and then I tabulate my accuracy and mean squared errors which is available. So I am at the 85th epoch. I'll give a minute or so. It should complete all the 100 epochs. Yeah. Now if you see this, it saved the model, and then within the model I go here. You see this, it started with a lower accuracy. Unlike the previous graph, it climbed up and the final accuracy is around 91%. All right, so that is how your neural networks work. Okay, so with this we come to the end of this session. Thanks everyone, take care, bye.